Hey folks, my name is Michael Mattsson. I'm a tech marketing engineer with Hewlett Packard Enterprise. Many infrastructure engineers are faced with rising costs of private cloud hypervisors and are looking for more cost-efficient solutions. A popular choice is running virtual machines on Kubernetes using KubeVirt. There are many tools in the market that allows transforming VMs and copy data out from legacy infrastructures onto Kubernetes. HPE has a unique capability within their CSI driver that allows seamless transitioning of a vSphere virtual volume into persistent volume that can be attached to a KubeVirt VM. The topic of today is how to iterate over a migration workflow with the endgame of transitioning a virtual machine workload from vSphere to KubeVirt. The starting point usually consists of a virtual machine running off a data store attached to vSphere. For the migration workflow that we're going to talk about, the virtual disk needs to be served from a vVol data store. With the correct vSphere licensing in place, it's trivial to perform the data migration non-disruptively while the VM running from one data store to another with storage vMotion. Once the VM is in place, we can begin to work against our goal, running the machine on KubeVirt after transforming the virtual volume to a persistent volume. Since migrating applications from one infrastructure platform to another isn't trivial, we want to be able to test the migration properly to ensure file systems are mounted where they should be, the application starts as it should, and we can perform basic sanity checks. So we want to start by cloning the source virtual volume into a persistent volume and poke around at the destination, so to speak, before we commit to actually performing the actual migration. And we want to be able to do this non-disruptively. And once we have the confidence that the transition will work, we can shut down the source VM and perform the cutover. At the end of this demo, we'll have the database running in a KubeVirt VM. I do want to emphasize that we only care about the source application's data. The destination VM has been deployed and configured according to the platform's best practices, and we're not really interested in resolving guest operating system device driver related issues. I would consider decoupling application runtime from data being the optimal pattern, regardless if you're running your application on a bare metal server, in a virtual machine, or a container. A handful of Ansible playbooks have been created to assist with some of the most mundane tasks that we're going to perform throughout this migration. All the example manifests and playbooks used in this demo are available on developer.hpe.com. Just search for KubeVirt. First off, we're going to run what against the source and the destination VM, and that will reveal that the legacy VM is running on vSphere and the destination VM is running in a KVM virtual machine. An Ansible playbook has been created to install and set up a database on the source and destination virtual machine. Will ensure to mount the data volume where the application expects it and set all the correct permissions and ownerships in the file system itself. The source will be populated with a test database that comes with a set of validation scripts that will also be made available on the destination for verification purposes. The test query calculates checksums of the contents in the tables, and it also outputs the host name where the database is running, so we can observe which VM we're truly connected to. Once the validation has completed, we can switch over to vCenter and find the name of the source data volume that we will need to create the persistent volume clone with. So we need to launch the HPE Storage Integration Pack for VMware vCenter and browse to the vVol backed VM to find the actual data volume's name. I know it's the 128 gig volume that I set up prior to this demonstration. The storage class has been configured to allow override parameters: import volume name, which is for cutting over a volume, and import vol as clone to clone a volume on the array into a persistent volume. For the cloning exercise, we'll add the volume name as a CSI driver specific annotation that will add the parameter to the provisioning process of the persistent volume. We'll create the clone and then log into OKD, the community version of OpenShift, where the VM is running. The PVC we just created can be attached during runtime and will be presented to the guest operating system shortly after. And once the PVC has been attached, there is a migration playbook that will mount the disk where the application expects it. And we'll start up the application and we'll run the test query against the database. And we can clearly see that the data is intact and the database is running inside the KubeVirt VM. So we're basically now ready to migrate the workload from vSphere to KubeVirt. The next few steps will revert the attachment of the clone to the guest operating system and cleanly remove all the residual devices and such. And back in OKD, we will detach the disk from the VM and delete the PVC. In vSphere, we'll simply shut down the virtual machine. Back at the prompt, I've prepared a PVC with the import volume name annotation, and all I need to do is paste the volume name from the previous step. We need to follow the exact same procedures of attaching the PVC to the running KubeVirt VM as we did previously. The migration playbook is oblivious to the fact that the volume we're starting the database on is a clone or the real thing, which in turn gives us the confidence that the migration will just work just the same as it did with the clone. Alright, so the results are in and the database has been migrated to KubeVirt. Back at vSphere, we can simply delete the VM. The references to the vvol no longer exist in the storage system, and the physical volume has been renamed. As the migration playbook is idempotent, we can run again, expect the same result, and we can make sure that the application is still working after we deleted the source VM from the legacy infrastructure. And that one last assertion concludes this demo. The key takeaways from this workflow is that the source volume and all its data is untouched during the transition. Also, the cloning process can be performed as many times as needed to perfect the destination environment. If you would like to know more about persistent storage for Kubernetes, visit hpe.com/storage/containers to learn more. Thanks for watching and hope to see you again soon. Take care.